For this example, we want to find the radius of convergence and the interval of convergence for the power series, where the nth term is given by n to the n power times x minus 4 to the n power. Because we have these exponents of n on each factor of the term, I'm going to change tactics a little bit, and instead of using the ratio test, I'm going to use the root test. For the root test, I need to look at the nth root of the absolute value of the term a sub n. So that gives me the nth root of the absolute value of n to the n power times x minus 4 to the n power. I can rewrite the radicand here as the quantity n times the absolute value of x minus 4, all raised to the nth power. Then the nth root of this nth power just gives us n times the absolute value of x minus 4. Now we can tell if we take a limit as n approaches infinity, we will get infinity because of the factor of n. There is one exception. If x minus 4 equals 0, or in other words x equals 4, then each term in the sequence n times the absolute value of x minus 4 will equal 0, and in that case the limit will be 0. So the limit in the root test is infinity unless x equals 4. As a reminder, the root test tells us that our series converges if the limit as n approaches infinity of the nth root of the absolute value of a sub n is less than 1, and our series diverges if that limit is greater than 1. Well, the limit we got for our problem is infinity. For which x values is infinity less than 1? Well, none of them, of course. So that tells us that our series diverges for all x values except the x value 4. When this happens, we say that the radius of convergence is 0, and the interval of convergence is the single number 4, which we write using set notation. Now, I used the root test here, but your gut reaction might be to use the ratio test. So I want to take a moment and show you how that would go. For the ratio test, we will look at the absolute value of a sub n plus 1 divided by a sub n, which is the absolute value of n plus 1 raised to the n plus 1 power times x minus 4 to the n plus 1 divided by n to the n power times x minus 4 to the n. We can rewrite n plus 1 to the power n plus 1 as n plus 1 to the n times n plus 1. And we can cancel n factors of x minus 4, leaving us one factor of x minus 4 on the top, and the n to the n power on the bottom. Now the two expressions raised to the nth power can be combined as the fraction n plus 1 divided by n raised to the nth power. Then we multiply by n plus 1 and the absolute value of x minus 4. That first fraction can be simplified as 1 plus 1 over n, all raised to the nth power. Then we multiply by n plus 1 and the absolute value of x minus 4. Now as n approaches infinity, we have a special limit. 1 plus 1 over n to the n power approaches the number e. The factor n plus 1 approaches infinity as n approaches infinity. So altogether, as n approaches infinity, our ratio approaches infinity, again unless the factor x minus 4 equals 0. Now we finish off just as we did for the root test. When is infinity less than 1? Well, never. So our radius of convergence is equal to 0, and our interval of convergence is equal to the single value 4.